Okay, so I wanted to explain the project, capstone project for Kaggle, in which we are using RAG, retrieval augmented generation, using Gemini API. So the first thing is I'm going to provide a bit of context. What I have done is to read some documents about the Pharmacopeia. The Pharmacopeia are the standards used to identify substances or drugs by the scientists. So in this case, I connected to the World Health Organization site, and in there I could get documents, the standards. In this case, I just limited the scope to ibuprofen. So the ibuprofen substance is going to be described with these documents that include how to identify the molecule, what tests are required to achieve the identification, plus how those tests must be applied, which are the methods. So, first things, as you can see, I've been executing, installing Gen AI API 1.7 ChromaDB for the RAG system. I also have implemented the key, of course, in Kaggle. Then first, I just try to upload a document just to test summarization. It actually works quite good, just providing information based on the document, which is very important for scientists to only get the information that's included in the standard. And then also I tried to go a step further and asking the Gemini model if it could create a database tables schema in order to prepare my laboratory system to have also a possibility of recording and storing the information of my tests. So for that, I changed the temperature to 0.7 to allow a bit more creativity from the Gemini large language model. And it provided me, as you can see, all the structures of the tables that I would need to create my LIMS or my laboratory system database. So this is one project. And also, I wanted to some evaluation of these answers, as we have seen in the exercise. So I wanted to just make the model check its own answers based on the prompts that I have generated, the criteria, in order to test the groundness, consistentness, and all these features that are important. And it rated them as 4, but also I asked it to rate the database structure that it generated, and it rated it as a 5. So that worked quite good. It's really helpful for later maybe adding this input in a further solution. Well, then let's go creating the embeddings database. I use ChromaDB as in the example, but I also tried, because of the documents are in PDFs, to get the chunks of data of text, I use PyMu-PDF. I connected it, upload the 5 documents that are included in the World Health Organization Pharmacopeia, ibuprofen PDF, spectrophotometry PDF, heavy metals PDF to identify the limits for those heavy metals and how to test them, and chromatography, which are the 2 methods used by the standard. Additionally, you will see this document that I uploaded to the Kaggle because it includes information about the database creation. And I want my system to also have the info about how to create those tables and those columns for my LIMS database in this time. So we have 2 databases, the embeddings and the SQL database. We prepare all these documents, and then we're going to read the chunks of data. First, we create the database, the embeddings database, ChromaDB, and then we use fits to get the text from the PDF files that will be inserted into our embedding database, and we will create the Gemini embedding function that will be used by my API. So we have the 6 documents ready and loaded into the persistent RAG database, embeddings database, the vectors database, and then I test it just by asking a query using the embedding function. What are the identity tests that I need to do to identify ibuprofen? It just provides a great answer describing everything we need. So, what did I do as a final cell in the notebook, which is awesome? And it's to create a chat that can use both the embeddings database to answer based on the documents from the Pharmacopeia, but also I created a set of functions, SQL functions, as we saw in the exercise, that are going to help me ask the Gemini model to insert information into my SQL database in this time. So we have insert monograph in case I would like to add additional information for other monographs. In this case, we just have ibuprofen. Also insert test, where we can see for that monograph what tests to identify the substance are available. We also have the parameter, because as you could see in the documents of the Pharmacopeia, the parametrization of these tests is crucial to follow the standard. And of course, another function to insert the test results, and another function to insert the results of the parameters, so the values from the parameters. I added another function that will retrieve, query the last test inserted. So basically, with a delta of 30 days, give me the last 30 days old tests. And then I added also functions like list tables to retrieve the name of all the tables of this database, and also retrieve the schema of the tables. So this is awesome because I added also a self-timer in order to close this chat, as the chat, in this case, there is no function, there is no application for the chat. We just leverage the Kaggle capability of the Jupyter Notebook to show and interact as a chat with a loop. So we can test it. As you can see, I have been doing some tests with it. And what I have done is that I included the capability for the chat to answer. I'm going to show you the example. So I asked the chat, hello, can you help me to insert data? And it said, okay, I can help with that. Tell me what you want to insert. It described what functions it has. Sorry. So I provided a record, imagining that I have already done my test following the standards and I want to get the results. So to store them. So the test, pharma customer, batch ID, analyst ID, which is myself in this case, the date, the status, and the comment. So in this case, it's pretty simple, but it could get as complex as possible to design an agent, which is out of the scope of the solution I just provided. But well, that's what I wanted to show you. So thanks a lot for listening, for your attention, and looking forward to continue working with this ultra useful technology. Thanks a lot.